Imagine a world where only two humans exist, just two souls alone on an entire planet, tasked with the monumental challenge of repopulating the Earth. Could they repopulate the Earth? This question isn't just a thought experiment, it delves deep into the realms of biology, genetics, and human survival. It's a question that has intrigued theologians, scientists, and philosophers for centuries. From ancient texts to modern scientific debates, the idea of starting humanity anew with just two people has been a topic of endless fascination. The story of Adam and Eve paints a picture of a world populated by their descendants. This biblical narrative has shaped much of our cultural understanding of human origins. But could two individuals really give rise to the billions of people alive today? The science behind this is complex and layered. The answer, as science reveals, is far more complicated than a simple yes or no. It involves understanding genetic inheritance, mutation rates, and the sheer improbability of maintaining a healthy gene pool with such a limited starting point. The survival of a species hinges on its ability to adapt and evolve. This process is driven by natural selection and the genetic variations that arise over generations. This adaptation, in turn, relies heavily on genetic diversity. Without a wide range of genetic material, a population cannot effectively respond to environmental pressures. This diversity, the variation in genes within a population, is essential for resilience against diseases, environmental changes, and other challenges. It ensures that some individuals will have the necessary traits to survive and thrive. Without it, a species becomes incredibly vulnerable. A lack of genetic diversity can lead to inbreeding, genetic disorders, and an inability to cope with new threats, ultimately risking extinction. The biblical story of Adam and Eve, the first man and woman created by God, provides a foundational narrative for many religions. This ancient tale has been passed down through generations, shaping the beliefs and values of countless cultures around the world. According to the book of Genesis, from these two individuals sprang the entirety of humanity. This narrative suggests that all human beings are interconnected, sharing a common ancestry that traces back to the very beginning of time. This story has been interpreted in various ways, with some viewing it as a literal account of human origins, while others see it as a symbolic representation of deeper truths about human nature and our relationship with the divine. But at its core, it proposes a scenario where two individuals are responsible for the incredible genetic diversity we see today. This idea raises intriguing questions about how such diversity could arise from a single pair of ancestors.
While the story of Adam and Eve provides a compelling narrative, it is essential to consider it alongside modern scientific perspectives. The fields of genetics and evolutionary biology offer valuable insights that can enhance our understanding of human origins. It's important to examine it through the lens of modern scientific understanding. By integrating scientific knowledge with traditional narratives, we can gain a more comprehensive view of our past. Advances in genetics, particularly in the last century, have given us unprecedented insights into the mechanisms of inheritance, population dynamics, and the crucial role of genetic diversity. These discoveries have revolutionized our understanding of how genetic variation arises and is maintained within populations, and the crucial role of genetic diversity. This diversity is not only a testament to our shared heritage, but also a key factor in the adaptability and resilience of human populations. By studying genetic diversity, scientists can uncover the intricate patterns of human evolution and migration, shedding light on the complex history of our species.
One of the immediate concerns with a population originating from just two individuals is the issue of inbreeding.
Inbreeding, the mating of closely related individuals, significantly increases the risk of genetic disorders. This is because individuals who are closely related are more likely to carry the same recessive genes. When two individuals carrying the same recessive gene for a disorder reproduce, there's a high chance their offspring will inherit two copies of that gene, leading to the disorder manifesting. Common examples of genetic disorders often linked to inbreeding include cystic fibrosis, sickle cell anemia, and Tay-Sachs disease.
To understand why inbreeding poses such a significant risk, we need to delve into the concept of genetic diversity. Each of us carries a unique set of genes, half inherited from our mother and half from our father. This genetic makeup contributes to our individual traits, from eye color and height to susceptibility to certain diseases.
Genetic diversity within a population is like a safety net. A diverse gene pool ensures that even if some individuals carry harmful mutations, there's a lower chance of those mutations becoming widespread. This diversity also provides the raw material for evolution, allowing populations to adapt to changing environments and challenges.
Section 5. When genes go missing. When a population originates from a very small number of individuals, a phenomenon known as a genetic bottleneck occurs. Imagine pouring a bowl of multicolored marbles, representing genes, through a narrow funnel. Only a fraction of those marbles will make it through, resulting in a less diverse mix on the other side. Similarly, in a genetic bottleneck, only a limited portion of the original population's genetic diversity is passed on to future generations. This loss of genetic diversity can have severe consequences for a population's long-term health and survival. Section 6. The case of the black-footed ferret. The black-footed ferret, a small mammal native to North America, is a stark example of the dangers of genetic bottlenecks. Once thought to be extinct, the species was brought back from the brink by a captive breeding program in the 1980s. However, the entire population descended from just 7 individuals, creating a significant genetic bottleneck.
As a result, the species suffers from low genetic diversity, making it more susceptible to diseases. Conservationists and scientists are working tirelessly to introduce genetic diversity into the population, highlighting the crucial role a diverse gene pool plays in a species' survival.
Section 7. Genetic bottlenecks, a closer look. Genetic bottlenecks can occur for various reasons. Natural disasters, disease outbreaks, or human activities like habitat destruction can drastically reduce a population's size, leading to a bottleneck. The smaller the population and the longer it remains small, the more severe the loss of genetic diversity.
One of the consequences of reduced genetic diversity is an increased risk of inheriting harmful mutations. This can lead to a higher prevalence of genetic disorders within the population and reduce overall fitness and adaptability.
A diverse gene pool is crucial for a species' ability to adapt to environmental changes. When a population faces a new challenge, such as a new disease or a changing climate, individuals with certain genetic variations may be better equipped to survive and reproduce. This process, known as natural selection, allows beneficial genetic variations to become more common over time, enabling the population to adapt and thrive in the face of change. Without sufficient genetic diversity, a population's ability to adapt is severely limited, making it vulnerable to extinction.
While the story of Adam and Eve holds religious significance for many, from a scientific perspective, it's highly improbable that the entire human population could have originated from just 2 individuals.
The genetic diversity we observe in humans today is far too vast to have arisen from such a small starting population. Furthermore, the concept of a single ancestral couple for all of humanity contradicts the fossil and genetic evidence supporting human evolution over millions of years. The human story is one of gradual change and diversification, not sudden creation from a single pair.
Science provides us with a powerful lens through which we can examine the world around us, including ancient narratives. While religious texts can offer moral guidance and spiritual inspiration, they should not be interpreted literally as scientific accounts of history or the natural world. The beauty of science lies in its ability to constantly refine our understanding of the universe as new evidence emerges. By embracing scientific inquiry, we can continue to unravel the mysteries of our world and appreciate the complex processes that have shaped life as we know it. The question of whether 2 people could repopulate the Earth reveals the intricate workings of genetics, evolution, and the delicate balance of life on our planet. Our DNA holds the secrets of our past, the blueprint of our present, and the potential for our future. It is a complex code that has been written and rewritten over millennia, adapting and evolving with each generation. While the biblical story of Adam and Eve provides a captivating narrative, it is but one of many stories that humans have told to make sense of our origins. Scientific evidence points to a far more complex story of human origins. Fossils, artifacts, and genetic studies reveal a rich tapestry of human evolution, with many branches and interconnections. The vast genetic diversity we observe in the human population is a testament to our species' long evolutionary journey. This diversity is not just a record of our past, but a key to our survival and adaptability. It is a diversity that should be cherished and protected, for it is the foundation of our resilience. Biodiversity in all forms, from the smallest microorganisms to the largest mammals, plays a crucial role in maintaining the balance of our ecosystems. For it is this very diversity that makes us resilient, adaptable, and capable of facing the challenges that lie ahead. Our ability to work together, to innovate, and to adapt is what has allowed us to thrive in a constantly changing world. The story of life on Earth is a grand tapestry woven from countless threads, each one representing a unique journey. These threads are interconnected, forming a complex and beautiful pattern that tells the story of life itself. Each species, each individual contributes to the richness of this tapestry. The genetic legacy of every living organism is a testament to the diversity and adaptability of life. And it's a tapestry that grows richer and more resilient with every new variation. As we continue to explore and understand the complexities of life, we add new threads to this ever-evolving masterpiece, ensuring that the story of life on Earth continues to unfold in all its diversity and wonder.